Right, so we're going to start quadratic attributes today. You know what a quadratic function is. We've dealt with them. They're the ones that have ax squared plus bx plus c. This is a standard form of a quadratic. Now when you graph it, we're going to see that our quadratic function makes what's called a parabola or a U-shaped graph. Okay, it's a U-shaped graph. This is my standard form. So when looking, my first question is the above function in standard form? It's x squared plus 6x plus 9. We would say yes, it is. So if no, what is standard form? Well, for our purposes today, we're going to go ahead and write that it's x squared plus 6x plus 9. So then we can use that for our notes moving forward. So when looking, it asks, we need to remember, it says, what is my a value? Well, from standard form, a is the number that's in front of the x squared. So in this case, there is no number, but there is an x squared, meaning that my value is 1. Then it says, what's the b value? B is the number that's in front of the x. So in this case, that's 6. And then the c value is the number at the end that's by itself. In this case, it's 9. The c value is also important because it tells me my y-intercept for the graph. You don't even need the graph. I mean, if you need it, you can look at it. From our picture, it doesn't go all the way up, but you could graph it on your calculator. But your y-intercept is 0, 9. Or, over here for your notes, 0, c. Okay? So then it asks, what is my x-intercept? Your x-intercept is where that graph touches the x-axis at. Okay, so looking, if we look, it touches at -3, 0. Then it asks the number of solutions. Notice I made it purple because we need to remember our vocabulary words. So number of solutions, we need to remember our vocabulary words is that it's also zeros or roots. It means x-intercept. All 4 of these words, these 4 words all mean the same thing. X-intercept, 0, root, solution. How many times did my graph touch the x-axis? For this example, we have 1. Keep in mind with quadratics, it could be 0, 1, or 2. It could be any number of those solutions, but that's it, 0, 1, or 2. So then our next question asks, does our parabola open up or does it open down? So looking at my graph, if I highlight my actual U-shaped graph, the parabola, we notice that it opens up. If it opens up, this means that it's going to have a minimum. And just look at the graph, it makes sense. If it's opening up, then it's going to have a minimum value. It's going to have a lower value. If it's opening down like this guy over here, then it's going to have a high point or a maximum value, but we'll get to that. So it opens up. Then it asks for the vertex. So I want us to use our calculators for this one so we can do it because that will help you out. If you go to new document, you want to save, say no, go to add graphs and type in x squared plus 6x plus 9. Okay, so we have our graph. It's the same graph. Our steps to get to the vertex are that you touch menu, analyze graph, and then you select, did we have a minimum or a maximum? In this case, it's minimum, so you pick that. It says lower bound. That means you want to be to the left of your parabola. See how it says lower bound in the left-hand corner? So you want to be on the left-hand side. Click your mouse, and then if you scroll over, you can see that it highlights.
Tell me these yours before I grab them off.
So then you click again to set the upper bound to the right of it, and you see that it pops up with your vertex, -3, 0. So that's my vertex. Your calculator can be used to help you find that. So then it asks for your minimum or maximum value. So remember, your minimum value or max, it doesn't matter, is the y value of your vertex. Okay, so if you can identify your vertex, you can identify the min or the max value. So going back to, let me find another color. Your vertex, you can see that the y value is 0. Okay, so my y value is 0, meaning that my minimum value is going to be 0, meaning what's the lowest point. Okay, so then for domain, you're looking at the x's. We need to remember domain going up and down. Looking at my picture, if you look, it doesn't even start until x is 0, and then it goes up. It has arrows on both of these because it continues in the up direction. So that means we're going to write an inequality statement saying that x is greater than, if you look, it's all to the upward side of the x-axis. So x is greater than or equal to 0. And then your range, let's do the x values, if you remember, are left and right, right? Because it's the x-axis. Going left to right, over here is the arrow, over here is the arrow, so that means that your domain is going to be, all real numbers. If this wasn't the 4th time to make this video, I'd start over, but all real numbers. So the range is what I was thinking of. It's the y values. Okay, so we're looking at up and down. Your range can go back to your minimum or maximum value. And if you look, our minimum value was 0, so we just need to know, are our y's above it or are our y's below it? Well, in this case, looking, our y's are going to be above it, meaning that y is greater than or equal to 0. All right, so we're going to go quickly through the second one. I should have given you enough time to try on your own. So is the above function in standard form? Yes, it is. And I'm going to rewrite it right here, negative x squared plus x plus 6. Then as I highlight for my values, you're just checking that you have the correct answers. If not, you need to ask questions. So my c value is also my y-intercept. So my a is -1, b is a 1, c is 6, making my y-intercept 0, 6. Your x-intercept, in this case, looking at my graph, there are going to be 2 of them. If you look, it's right here, which is -2, 0, and right here, which is 3, 0. So then it asks number of solutions. Well, this time there are 2. Does my parabola open up or down? In this case, it opens down. So then that means it's going to have a maximum value. So we need to get our calculator out to identify the vertex. Let me scoot it over so there's no glare. So you do new document. You want to save, say no. Go to add graphs. Negative x squared plus x plus 6. And you do menu, analyze, and this time we have a maximum, so you want to be to the left. Then you want to highlight it, and this time we get that it's 0.5, 6.25. So my vertex, 0.5, 6.25. Remember, your minimum or max is the y value of your vertex. Where'd my green highlighter go? So in this case, it's going to be 6.25, which we can also use for our range. So this time it's a maximum value of 6.25. So then your range, if we look back at our graph, is it above 6.25 or below 6.25? Well, it's below, making my y values less than or equal to 6.25. And in this case, your domain, the x values, are still all real numbers. For the most part, your little hint, your domain is always all real numbers.